This is 17.1a notes, part 2. The typed stuff you see on this page right here basically covers everything I did in the first video. If you don't need any detailed explanation of this, don't worry about going back and looking at the second video. If you never saw this before, pause, go back to the last video, or just look carefully what's here. This should be reviewed from last year. We're going to work on using this stuff to do some problems. In the top corner here, I've written that sohcahtoa stuff that will help us figure things out. But we're going to take each of these pictures and we're going to figure out whether we should solve it using sine or cosine or tangent. I'm going to set up all 6 of them, then I'm going to come out and solve a few of them. Then I'm going to flip to another page where there's a typed version of the ones I didn't get to. Because again, I need to limit this to 15 minutes. Okay, first problem here. I have one angle, 55-degree angle, and I have a known side. My right angle is at C, so this must be my hypotenuse. And I have one more side, and it looks to me like this side is opposite to the one that I actually want to work with, the only angle I know. So, the thing that uses opposite and hypotenuse is sine opposite hypotenuse. I prefer to write it this way. Let's do this. Sine is opposite over hypotenuse. Okay, so this is the sine of the only angle I know equals the side opposite from that, which is my y, over my hypotenuse, which is 20. That's the basic setup. Let's look at the next problem. I'm going to do setup for all 6. In this one, the only angle I know is 35 degrees. And over here would be the opposite, but I don't have opposite. I have my hypotenuse because across from the right angle, the longest side of all is always my hypotenuse. And I have this z side, and the z side is coming down and touching the vertex of my 35-degree angle. That makes it my adjacent side. Now, out of the 3 that we know, the one that uses adjacent and hypotenuse is cosine. So cosine is adjacent over hypotenuse. Let's set that up. The cosine of the only angle I know equals the side that's adjacent to it over the hypotenuse. There's the setup for that one. Go over to the third one. Know one angle, 20 degrees. I see this one, which is opposite because it doesn't touch it. And then I see the 12-inch one, which touches it, but is not the hypotenuse. This is my adjacent. My hypotenuse is over here. My hypotenuse has no number. It has no letter. It's not very helpful to us this time. Of those 3, the only one that does not deal with the hypotenuse is tangent. So I'm going to say the tangent is the opposite over the adjacent. Come down here, let's set this up. The tangent of the only angle I know equals the side opposite from that over the side adjacent to that. And when they say 12 with those little double marks, quotation marks, it actually means inches, but we don't even care what it means. If you didn't know, it wouldn't matter. Unless you're going to build that triangle, nobody cares. As long as you put that on your answer too, you'll still be right, even if you can't figure out whether that's inches, feet, meters, miles, doesn't matter. Okay. The next section from the bottom is going to be just slightly different. We're going to solve it differently, but it doesn't look any differently when we're working it out. I'm dealing with my hypotenuse opposite from the 90, and the hypotenuse has a letter on it, so we're going to be using that. The only angle I know is 30 degrees. And this one doesn't touch it. It's my opposite. The one that uses opposite and hypotenuse is sine. Sine is the opposite over the hypotenuse. So I'm going to say sine of the only angle I know is the side opposite over the hypotenuse. Letter on the bottom makes it just a little different when we actually work it out. Look at the next triangle. Only angle I know is 45. We'll find a better way to deal with 45, 45, 90 triangles later, but that's okay. I have my hypotenuse, the longest side, the side that's opposite from our right angle, and then I have this 10 with a single mark, which means 10 feet. But again, who cares that it's feet? And it is touching the 45-degree angle, which means it's the adjacent side. The one that uses hypotenuse and adjacent is cosine. Cosine is adjacent over hypotenuse. So I'm going to come down here and set this up. Cosine of the only angle I know equals the side adjacent over the hypotenuse. One more setup, and then we'll start doing some solving. The only angle I know is 40. Here's my hypotenuse, opposite from the 90, but it's kind of worthless at this point because there's no letter, no number. I have to say opposite, not touching, 10 feet. Adjacent, touching the 40-degree angle, is the M. Opposite and adjacent is tangent. Tangent is opposite over adjacent. Let's do the setup for this problem. We're going to say tangent of the only angle I know equals the side that's opposite over the side that's adjacent. Notice that on the top line, every problem had the letter on top of the fraction. On the bottom one, every fraction had the letter on the bottom of the fraction. They're both equally valid setups, just a little bit of difference in the solving. Let's go back and solve one or two from that first line. Solve the very first one. In my opinion, the easiest way to solve this is to say, I need the y by itself, I need to get rid of the 20. I can multiply both sides by 20, but I generally just call this cross multiply. That's 20 times sine 55 equals 1 times y, or just plain y. And then I'm ready to put this in my calculator. In most calculators, you're going to be better off if you do 20 times sine 55 instead of trying to do sine 55 times 20, because you could add parentheses issues if you put the 20 in the back. If I put this into my calculator, it tells me 16.38304 equals my y. The directions on this thing say round to the nearest hundredth, and you should always look at the directions and see what's going on. When they ask for the nearest hundredth, they're asking for 2 places past the decimal. I think that in our assignment, they asked for the nearest tenth. Before I finish, I'll go back and show you a separate page where I've typed the answers for the ones I haven't done, and I've also given the answer to the nearest tenth, just in case you need to look at them. So nearest tenth means I want 2 places past the decimal, and the number that follows after those 2 places is a 3, so I don't have to push it up any. This is just 16.38. It was originally in feet, so my answer should definitely have feet on it. Okay. To me, that top line with the letters on top is the easier one of the two. Let me choose one from the bottom to work for you. Let's work this middle one on the bottom. I'm still going to start with cross multiply. I've got the p, I've got the cosine 45, and equals 10. The problem with this is my letter's not automatically by itself. So I'm going to say I need the letter by itself, I need the cosine gone. can't get rid of cosine without getting rid of the 45 at the same time. They have to stay together. They're a single unit. So I'm going to divide both sides by cosine 45. Divide both sides by cosine 45. I'm going to put that into my calculator. That's going to turn out to be P equals 14.142 and so on. Since I want the nearest hundredth, I'm going to say 2 places past the decimal. 2 is not 5 or larger. It can't push it up. 14.4. The original mark had that little, original problem had that little 1 mark thing. It actually means 14.4 feet. But if you left it with a single mark, it's really not a problem, even if you don't know what it means. Unless somebody asks you to build that triangle, nobody cares whether that's 14 feet or 14 inches. Okay, let me do another one from this bottom section. Let's do a tangent one, because I haven't done a tangent yet. Again, I'm trying to get the letter by itself. I'm going to put a 1 underneath here. I'm going to cross multiply so that I have m times tangent 40 equals 10. Still need the m by itself, so I'm going to divide both sides by tangent 40. Tangent 40. This makes my tangent 40 cancel out, and I get m equals, in my calculator, 10 divided by tangent 40. And again, depending on your calculator, it is possible that you might need to throw some parentheses around there. And I end up with 11.917. In this case, I'm looking for 2 places past the decimal. And that 7 is a little bit larger than 5. So instead of writing 11.91, I'm going to write 11.92. It's that 7 that makes my deciding factor. Original problem had feet. I'm writing it down with feet. And there's my answer. Pause it if you need to look at what we just did. But I'm going to show you page 2 here, where I've worked out every problem completely. Also notice that since our assignment asked for nearest 10th, not nearest 100th, I went back and I also gave an answer rounded to the nearest 10th for each of these problems. Okay, back side of the notes, one more video. I hope we'll fit the back page into a single video.